across on 5.3. What can I help you with? Number two. Number two says an agency charges $10 per person for a trip to a concert if 30 people go. Okay, so 10 for 30 people. But for each person above 30, the price will reduce by 20 cents. Okay, so this will be 10 minus 0.20x is one equation. And then this would be 30 plus x. And then how many people will maximize the total revenue if the trip is limited? So we can have at most 50 people on this trip. Okay, so we can go ahead and just graph this equation. There's no reason to go multiply it out. So let's bust out our buddy old Desmos. And Desmos does have some shortcomings to it because there are times where you try and plug something in and it's like, what? All right, so we get y, y equals, parentheses, 30 minus 0.2x, and then 30 plus x. Those are our two equations. All right, so we kind of have to find it. So zoom out until we find it. It looks like I found part of the red line. Let's make it a little darker. So it looks like if we, there we go. So here's the problem. That would be if 16 or 60 people went, we would have a maximum profit of $1,620. But they told us there was a maximum of 50 people that could go. So what I'm going to do is I'm going to go x equals 50 and then find that intersection. So it looks like if we have 50 people go, we would wind up making $1,600. Okay, so that one we kind of have to monitor because obviously that value, let's zero in on that a little bit more. So this, so because, you know, whether this is like, let's say you're taking a bus and there's only maximum 50 people can go, you can make $1,600. If for some reason you came up with a way to get it up to a higher number of people going, then if you brought in 60 people, you would maximize making $1,620. Okay. What else? Yeah.
Why would you have 30 minus 0.2x and then 30 plus x?
Oh, I probably made a mistake, didn't I? $10 per person. Oh, shoot. Sorry about that. That should have been a 10. Now we have to go find. There's our parabola. All right. Yeah, I made a mistake plugging it in. Thank you for finding that for me. All right, so it looks like if we add, is that the right equation? Is that the right equation in there now? Is that what I had on the last screen? 10 minus 0.2, 30 plus x. Yeah. So it looks like if you had 10 people going to this concert, you'd have $320. So then at 50, if you had 50 go, you're losing out. That's not good. So, yeah, so I don't think we need that. And the only reason I put that, we don't need that. We just needed, oops, come on. it looks like if we had 10 people go on this trip, that would be our maximum. That would be our maximum profit. So you're not, you could have 30 people going, but if you only brought 10, you're probably bonusing a lot more, making $320. All right, what else did you see? Yeah.
I just have another question. You said it was up to 50 people. Why would you make it like?
Yeah,
Well, would you make it X equals 20 because 20 if 20 is X, you're adding 20 to 30 and then it's 50. But if X equals 50, then it's 80 people total. So is it saying like up to 50 or 30 and then up to 50 extra people for like 15 people?
I think they were just trying to bound it. I think that might have been extra information on that problem.
Okay.
Yeah, especially in that case. If it wasn't my first case, it would have made more sense. But unfortunately, I think it was a too wordy of a question. I only think we need the first 2 sentences.
Okay.
So, or 3 sentences, but limiting it, not having the 50.
Okay. So that part doesn't.
Yeah. What else did you see on any of those on 5.3? Yeah.
Number
7. Backside. Weekly demand function for a product sold by one firm is profit equals 600 minus 1/2 x, and the average cost of production and sales. So your cost is 300 minus or plus 2x. All right, so find the quantity that maximizes, find the selling price for this quantity, and what is the maximum profit. All right, so I think I can plug all this in. We're going to do, we did cost minus profit. So cost was 300 plus 2x minus, notice I'm putting them in parentheses, 600 minus 1/2 x. And we have to find it now. Home. Oh, thank you. 2x. All right, so zoom out until we start finding this graph. Oh, are you kidding me? Y equals 300 minus 2x. Or plus 2x, jeez. Stirrup has lost his mind. And 600 minus 1/2 x. I forgot the subtraction sign. All right. Oh, it's 2 linear equations. All right, so this is not obviously going to help us because it's going to infinitely grow. So I think on this one, what we should have done is this. I'm going to graph the 2 equations. I don't necessarily independent of each other. So y equals 600 minus 1/2 x. There we go. That's a little nicer for us. All right, so you have 2 linear equations that goes, which means that if you produced 120 items, that would be your maximum profit would be $540. So what quantity will maximize the profit? 120. Find the selling price for this. So the selling price, if you just you're going to get the same thing. So the maximum profit is 540. The selling price to optimize the quantity. So A and B are both 120, 120. You made 120 products and you sold them for $120. That means you maximize the 540 because you just had 2 different linear equations. One was a profit margin and one was a cost to produce the item. So A is 120, B is 120, and C is 540. What else? Yeah.
Can you go over what did you say for B?
B.
Is it like is
Okay, so this is what's happening. Which one's purple? 600. So your profits are decreasing at a certain amount that are being produced. As I continue this way, I'm making less profit because it's costing too much to produce. So both my A and B value, because this is the intersection, are both good. If I make 120 items and sell them for 120, because that's the intersection of the green and the purple, but that would yield you a maximum profit of 540. So if you made, they cost $120, you made 120 total. If you, so basically what you would be doing is find the quantity that will maximize the profit. You plug, that's the 120.
So wait, isn't the quantity of product is 20? So if you're finding the price, would you do the revenue divided by 540 divided by 120 to find the individual product price?
Find the selling price to optimize the quantity. So you're saying,
because if you're 120 is the quantity, and the maximum profit is 540. So are they asking what is the selling price that each product would have to be to get these answers?
Yeah.
So you do 540 divided by 120, which is 4.5.
Oh, 4.5.
Yeah, isn't that, or is that not what the question's asking?
You might be, find the selling price. 540 divided by 120 gives you 4.5. Yeah. Oh, you guys are smart. I'm a little off my kilter today. I didn't sleep well last night, and then I actually woke up sitting out on my front porch to sleepwalking. I'm a blessing with my wife, so I'm definitely off my kilter. So who knows? Who knows what's going on? Any other questions from the homework? Going once, twice, sold. All right. All right. So, yeah, I think so 540 divided by 120. Let me just go back. So let's make sure that we said that right. So if you had number 7, if you had P equals 600 minus 1/2 X and cost equals 300 plus 2X, 20X. Because we had the two equations that crossed at 125.40. Is that what it was?
Yeah.
So yeah, so A, what quantity? You'd have to make 120 items. B is the selling, what price are you selling items at? So 540 divided by 120, I think that's great. Yeah. And you said 4.5 or $4.50 to be sold them for. And then C, what is our maximum profit then? We would make $540. So that's definitely good thought process. I appreciate that. What else do we see? Let's see if there's anything. Critical values, critical points, function increasing, decreasing, relative max min. Are we okay with number 8? That's just, again, Desmos will take care of you. Weekly revenue, critical values. Again, graph it. I don't think you want to do the derivative. It would be quotient rule. But if you have Desmos. All right. So let's take a look at worksheet 5.4. And let's take a look at, say, how number 1's done. They gave us this. X to the third minus x squared minus x plus 1. But then they give us this region from 2 to 0, which is kind of flip-flop backwards. All right, so if I had graphed this graph is going to look something like this. This would find us a max, and this would find us a min. Okay, the x value is the number of items. And then the Y value would be like a profit or a cost, depending upon what you're looking at. And then Y divided by X would be how much each one would cost. But I know it's not asking for that, but that's what it's taking place with. Total revenue for a widget company is that the sale of how many units will maximize revenue. So again, you're just looking to graph it. Find the maximum revenue if production is limited to 1,500 radios. So same idea. So the total number of widget companies, the sale of how many units will maximize. So if I plugged 1,500 in to this equation, R equals 36x minus 0.01 x squared. If you plug 1,500 in for x here and x here, that would get you that answer. Company manages apartment 50 units. Data has shown that it will rent each for $360 a month. All units will be filled. However, one unit will become vacant for every $10 increase in the monthly rent. What rent should be charged to maximize the total revenue of the building if the upper limit of rent is $450 per month? So number 3 is a unique question. My sister-in-law, so my wife's sister, she works, I can't believe she makes this much money. This type of question is what she does. She works for a leasing company for apartments. And so we'll literally go to certain apartments, do an analysis that if they increase their rent to a certain value or decrease their rent a certain value to get the optimum amount of people in the apartment complex. I will just say that the house that she lives in, well, she married a trust fund baby, so they're well off there, but she makes ridiculous money just figuring this out for apartments. And I sit there and look at it going, it seems so easy, but it has some research and stuff that goes with it. But club member charges $5 admission. Classic car show, 1,000 people will attend. For each dollar increase, 100 fewer people attend the show. So number 4 is one of the equations. We'll just take a look at this, and then you can write this down in it. So you have $5 admission for 1,000 people. 1,000 people. I don't know why I'm putting $1 with 1,000 people. So obviously that's $5,000. If you increase $1, you will decrease by this minus 100x. And if you graph this, that's going to yield you how much you should probably charge. So sometimes more people isn't always better. Sometimes less people is better if you're charging more, if it all works out in the right way. Bless you. Yeah, $1x. Total cost functions that. Producing units minimum average. Okay, so that's a parabola. Just graph that and find the vertex. A firm produces 1,000 units per month. Total monthly cost given by cost given by that. 300 plus 200x. Where x is the number of widgets produced of a total revenue given by Rx. So remember on number 5 or number 6, if you have C at x as this equation, C at x is 300 plus 200x, and then you have a revenue of x is equal to 250x minus 1 over 100 x squared. So maximum profit, find the maximum profit. So this would be revenue R at x minus C at x. Cost. No, I went backwards. C at x minus R at x. So if you graphed 300 plus 200x, and then you subtracted 250x minus 1 over 100 x squared. That's going to allow you for a maximum profit. So the x would be how many widgets you produce, what's the maximum profit, and that'll do that. And then number 7, you have cost and profit. You go with the same idea. All right, so let's have you guys and girls and friends do worksheet. All right, doesn't want to write worksheet 5.4. You should be able to handle it. Save